Hello, chemistry students. This is Miss Osterberg. We are going to be going over learning target 6.4 today. We're starting it. Do you remember back to when we did that chemical equations project? We had you find items in your house to make something. So I have taken 4 soup cans, which are these red things, and 1 box of cereal, and I made a table. And then you had to find the equation that fit your creation. And so this is the one that fits my creation. 4 of these x's, which are the soup cans, plus 1 of the y, which is the cereal box, is going to make me a table, x for y. And then you were given some amounts of things. So let's say that we have 20 cans. And let's say that we have 10 of these boxes. And we want to know how many tables can we make? So the way most of you did this is you said, okay, we have 20 soup cans. Every time we make a table, we need 4 of these soup cans. And of course, the goal is to make this table that looks something like that. And there is 1 of those. So 20 divided by 4, that's going to get you 5. I'm just going to write it out. Tables. 5 tables. These are the tables. Okay. And then if we have 10 of these boxes, right? Well, every time we do this equation, we need 1 box for every table that we have. Okay, and that's going to get us. So if we need 1 box for every table, if we have 10 boxes, we can make 10 tables. So then we asked you, okay, how many tables can you really make? Can you make 10? Can you make 5? Do you make 15 tables? And most of you said, you can only make 5 tables. And this is why. Once you're using the soup cans and the boxes at the same time. Every time you do this reaction, you need 4 cans and 1 box. So if you did this reaction once, now you would be down to 16 because you had to take 4 away from 20, and you'd be down to 9 because you had to take 10 away from 1 to make 1 table, okay? So really only 5 tables can be made because once that 5th table is made, you've used 20 cans. We call this the limiting reactant. The limiting reactant. And the limiting reactant is the chemical or the thing that's going to limit how much product we can make. So this chemical limits how much product can make. It's the thing that's going to run out first. It's the chemical that limits how much product we can make. And we know that it's a limiting reactant. Now, again, reactants are the things that we use to create our product. The table is the product. We know it's the limiting because it's producing the least amount of product. So it produces the least amount of product. So we can only make 5 tables here, okay? We call this other thing, we're not going to do too much with this guy, but just so you know, the the cereal box is this Y. This is called our excess reactant. Okay. And that's because we have tons of it. We have lots of it. We're never going to run out of it because we're going to run out of our limiting first. So you may have seen this. It says, 5 grams of sodium chloride reacts with excess silver nitrate. That means we have tons of silver nitrate. So that's what excess means. All right, so let's scroll down and let's look at an actual chemical example. I'm going to show it pictures first, and then we're going to go on to the math so you can see this. So we have nitrogen, and so that's going to represent our nitrogen, our N2, and we have 3 hydrogens each time, and they are going to make 2 ammoniums. Okay, so we have 12 moles of H2 in this problem, and we have 10 moles of N2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 moles of N2. And that means that we also have 12 moles of the H2. Okay. And we want to know how many moles of ammonium we're going to make. So every time we do this problem, this is our recipe right here. We need 1 nitrogen and we need 3 hydrogens. And those come together and they make 2 NH3s. I'm just going to write it out right here instead of doing these guys. I'm going to write it out. 2 NH3s. So let's take another one, and we're going to take another 3, and those go together to make 2 more NH3s. Okay, and we can take another one, and we can take another 3, and those go together to make 2 more NH3s, because every time we do this, we make 2 of them, right? And then we'll take this guy, and we'll take, we have 1 more for these last 3, and they go together to make 2 more NH3. So we have 1, 2, 3, 4, 5, 6, 7, 8. We can make 8 NH3s. Okay, 8 NH3s. If we have 10 moles of N2 and 12 moles of H2, okay? And that means that this H2 is our limiting. And this is our excess. Okay, let's show it with math. If we have 10 moles, I'm actually going to do that in green just to keep it. We have 10 moles of N2. Every time we do this reaction, we need 1 mole of N2 to make 2 moles of NH3. So if we had 10 moles of N2, we could make 20 moles of NH3. And if we have 12 moles of H2, well, every time we do this reaction, we need 3 moles of H2, and that will make us 2 moles of NH3. So that means that we can make 8 moles of NH3, which is what we found up here, which means, again, that the 12 moles of H2, this is our limiting. This is what limits. We are going to run out of it. So this is our limiting reactant. We're going to run out of it. We can only make 8 moles of NH3, and we are going to be limited by our H2. So that's a little bit about how to do this. You don't always have to draw the pictures. Sometimes pictures are more trouble than they're worth. But you do always have to show your math down here. Thank you, and reach out to your chemistry teacher if you have any other questions.